So you can actually take two totally different GraphQL APIs, join them inside of Hasura, get all the benefits like row-based and column-based permissions and all the kind of functionalities that you like working with Hasura, and be able to get all the benefits of that for all of your external APIs.
The first type of join that I think we made available was the ability to do like just standard remote schema joins. So if you have a database table and you have a GraphQL service, you were able to sort of make an association between a particular column in a database table and an input field to a GraphQL resolver, right? And so you could query like with DB to DB joins, you can essentially say, all right, I have customers in Postgres and I have payments in SQL Server, and I want to make like a virtual join or a virtual foreign key between those two tables. And in GraphQL now you can just query them, and Hasura will do a bunch of magic behind the scenes.
Hello, everybody, and welcome to another Data and API show where we have a brand new format for you. We are now going to be releasing these as weekly drops, where we will be condensing down the content into something hopefully more bite-sized, something that you can actually make more applicable. Because I just don't know if everybody's actually tuning in for 60 minutes of hearing me blab with some guest about nerdy topics every single week. So I think maybe there's more value when you're trying to look up how do I do X with Hasura, maybe a 20-ish minute condensed like actual listing of solutions is what you were actually hoping to discover. And to discover those kind of things on today's show, I am joined by a guest who is not going to be strange to anybody who's been following the show for a while, but has not been on the show in a long time. Gavin, how are you doing?
I am good, man. It's Monday.
Yeah. It's Tuesday. It's Tuesday. This is a Tuesday show. No, yeah, it's Monday. We're recording it on Monday. But yeah, it's great to have you here. If you're not familiar with who Gavin is, he is one of the wizards in the background at Hasura who just basically creates all of the amazing demo content that you often see. So super excited to have Gavin here. Personal note, Gavin has been one of the senseis for me here at Hasura when I've got a question on best practices, because you've got this box full of tools, here inside of Hasura. You could do so many things with this platform, and there's a lot of cases of but should you do it that way? And that's a lot of cases where Gavin's extensive experience inside of Hasura has really come in handy, from a community champion to now actually working inside the company as well, being able to say, here's actually some good practices or ways to solve some common problems. So super excited to have you here today. Yeah. So in that vein, if you followed us last month, you'll remember that what we did last month was a architecting with actions. And actually, I wasn't even thinking about this. We looked at the Hasura Super App, which was, in fact, built by Gavin, and I contributed a little bit of code and misdirection inside of that code base. But that was one of the first cases where I learned a little bit more about how it works. And then we did a deep dive on that this last month on architecting with actions, using both custom resolvers, as well as then using things like the new REST connectors, which didn't even exist when we built the Super App. So being able to cut out a whole bunch of code there as well. So that was what we did last month. We talked about these different functionalities. This month, we're looking at specifically on joins. And if you are familiar with anything happening in Hasura land, we just launched kind of a cool thing called GraphQL remote schema joins. So you can actually take two totally different GraphQL APIs, join them inside of Hasura, get all the benefits like row-based and column-based permissions and all the kind of functionalities that you like working with Hasura, and be able to get all the benefits of that for all of your external APIs. And so we're talking a lot about joins and how you actually go about architecting with that tool set, all for the upcoming month. And that to kick it off, today is architecture day. So talking about the what, the why, a tiny bit of the how, and really having an idea of sort of what it is that we want to do. So does that sound good, Gavin? We're going to have a talk about the high level and get people excited for the coming shows.
Let's do it, man.
A lot of people get horrified by the amount of micro applications I have running in my header there. But anyways, it's neither here nor there. I've got very simplistically here a education model, right? So we've got kind of an idea of a student. Students have guardians. Students are enrolled in classes. Classes have teachers. It's just kind of a basic model for what a school might look like, and this maps pretty cleanly to relational data sets, right? This is something that's kind of data that might be representative of something that an individual organization would probably own, probably maybe even have migrated from Access at some point or whatever. They've got like their own data set that they're now wanting to actionalize, if you will, or make it into something that can be turned into dashboards and utilities, and maybe be able to create some sort of interfaces for students. Blah blah blah. The story is always different, but always the same at the same time. What we got here is a data set we're trying to create an API for, and like that, we've done this, right, a million times on this show, where basically you throw it at Hasura and you give the database. Then you got basically all of your tables set up the way you would expect. So far, everything looks pretty standard, right, Gavin?
Yep. Looks like a regular old app.
A regular old app. So here's where then from the architecture perspective, and having built a couple of these sorts of cases for these sorts of people in the past, things that often will become varied. One thing that doesn't map cleanly in relational terms is like the kinds of quizzes and tests that a teacher may want to be able to provide for a particular subject. So there's so many multiple choice options. There's so many like long form options. And it feels like teachers often want that flexibility to be able to create tests essentially on the fly, if you will, where they're able to say, okay, next week I want to have these 4 questions and these things over here, and kind of slap something together. And you're a little bit stuck with either needing to have like an entirely different database or entirely different product that is focused around building quizzes and tests for students, which, I mean, they exist, right? Or you're needing to find some way to sort of introduce almost a schema-less content source that you can sort of federate into this API, and that's a really great case to then talk about joins. Yeah,
I would agree.
So the one case that I came up with, I was working on a demo for a MongoDB thing, and so one option I came up with was a collection in Mongo that's essentially free-form document store. I mean, that kind of maps pretty cleanly. But then you got cases like, again, where, again, building things for for these kind of people, they're not necessarily either wanting to create their new UI again, for a test builder, or maybe they're wanting to simply be able to capture free-form document style data that represent whatever kind of criteria a test represents, but they're wanting to maybe use like a CMS or something to be able to create this content. And if you're a school admin or you're trying to support this sort of a system, you're needing to find people that have solved some of these familiar UI patterns in the past. So maybe in one context, you're allowing people to create a CMS, like have a CMS interface, and you're not wanting to recreate that, which you can, like with Hasura or whatever else, but you're not wanting to specifically, and you're wanting to figure out how can I join maybe free-form content creation, free-form capture, highly structured, highly relational data. And so this kind of comes into the world of joins. about where would you start to store this different kind of information, and how can we sort of be able to bring them all together into a complete product picture. And so if you maybe you could give kind of a quick rundown for the people, what are the types of joins we have actually available like today inside of Hasura?
Yeah, so the first type of join that I think we made available was the ability to do like just standard remote schema joins. So if you have a database table and you have a GraphQL service, you were able to sort of make an association between a particular column in a database table and an input field to a GraphQL resolver, right? And so you could query like, imagine you have a user has like a Stripe customer ID in your DB, and then you have a Stripe API, right? So you can make a relationship and say, all right, my Stripe customer ID is a relationship that should be fed as an input to the Stripe GraphQL API, and then you can just query all of that. The next thing that we released after that was DB to DB joins. So imagine if you are working on an app and you maybe inherit some legacy data or a legacy system, and suddenly you have data in two sources. With DB to DB joins, you can essentially say, all right, I have customers in Postgres, and I have payments in SQL Server, and I want to make like a virtual join or a virtual foreign key between those two tables. And in GraphQL, now you can just query them, and Hasura will do a bunch of magic behind the scenes. Kind of the last thing that we released, like Jesse was talking about, is this, GraphQL joins, which is this ability to make, GraphQL API to GraphQL API joins by kind of correlating different resolver inputs and outputs.
Yeah. Okay. Yeah. So we've got the GraphQL to DB, or the remote schema to DB, DB to remote schema. That one's also released. Yeah. So we can go both directions on that one.
Yeah.
And then we have the remote schema to remote schema, and then we have the DB to DB.
Basically, we have everything except for actions. We have everything except for REST API to REST API, basically.
Okay, nice. When it comes to sort of then figuring out which data to let live, which data to leave in place, what would be sort of a guiding principle about when you would say, let's leave the data in the DB we inherited versus we're trying to just do a big migration to bring it over? Is this like an eventually migrated model? Are there cases where you would say they actually should always live in two different databases, and that's a case where then the joins have become a long-term solution?
Yeah. In my experience, because I've worked with a number of like legacy apps, whether it was like modernization or contracting, right? If the legacy data store isn't being written to anymore and it's not receiving new data that you have to try to stay synchronized with, it's a lot easier in the long run if you attempt to do a migration to the new data store. Because the big penalty, right, that you're paying for this really awesome feature of, joins between multiple data sources, is that there's not really an incredibly efficient way to do that. And what I mean is that you're always going to have to make at least one query per data source, and you have to pay the cost of the network called to each data source. And there has to be there's a cost to essentially joining them in memory and creating temp tables and other stuff, which is a little bit of a tangent. But to answer your initial question, if there's no more data going into the DB, I would say migrate it if you can. If the data is still being actively written to, even if it's infrequent, then it's a bit more of a headache.
Mm-hmm. What about cases where the data is inherently different and optimized to the database that it's being written into? So, right, maybe like you were saying earlier, I've got payment type information coming in. So transactional databases that are maybe matching their own quadrant of ACID complete, and then I've got my maybe some time series data that
Right.
is interactive or sensor based or something else. I'm not sure what sensors you'd be using in the school context here. We don't want to go too creepy.
Right.
But Gavin
Yeah,
just
no,
got up from his chair.
that's that's a good point. Yeah, I think if the data source that you're inheriting doesn't map to like your typical, like RDBMS like row store, um, it probably doesn't make sense to migrate it, because you're going to lose a lot of the qualities of whatever reason it was you used that database for in the first place, assuming it's a good fit. If it's one of those cases where like, you're a scrappy startup and you had, a young dev is like, oh, this data tech is cool. It's trendy. We're going to build on this. Maybe consider migrating that. But if you make a sound technical decision, you're like, we're using Cassandra because, XYZ, or we're using, Timescale because we have, high time series data. You probably don't want to move those data out of those data sources. So yeah, I think that's a valid reason to keep it there.
Yeah, I mean, so speaking of Mongo, no, I was just kidding. No, I mean that was like that, like the idea of a scrappy startup, getting going quick, and there was a phase, and you and I both are of the
Live
tenure,
through that, live through
uh,
that phase.
where we were kind of like, well, maybe SQL, right? So it was everybody had done no SQL in document stores, and in like a lot of cases overfit to that tool space. And so then there was some cases where if your problem is actually should be more in actually a relational database for read speeds or whatever else, then this is actually a case, or write speeds in specific. If you were to then say, oh, actually, this is a migration case, we'll bring this over, but potentially half of the documents still were actually intentionally. So there were some reasons, there were some benefits of NoSQL. So you could potentially say, we're taking half of the collection or these collections, putting them back into a proper proper in terms of like big P proper database, and leaving the benefits of a document store for what we had wanted that for. And now we're just going to bridge that gap over between the two of them with a connection.
Right. Yeah.
Yeah. Now that becomes more tricky, at least in terms of DB to DB, because it doesn't exist. Between a document store and Postgres. But then we actually have some solutions to talk about in this show. We can actually, maybe we'll even do a quick connection here, because I actually have a Mongo integration here for this specific project we can have a look at using a remote schema. But like, yeah, there's a lot of cases where potentially the DB, so if the DB is optimized for the data it's storing, and you have other data that's better optimized for other data stores, let them be. If you have data stores where the migration effort is not a priority and is not causing a lot of pain points in terms of solving, getting a production ready application up and running quickly, then like leave those in place as well. Because I mean, if you're talking about, again, let's go back to the education thing. We're talking about school onboarding is next week or like in a month or two, and you need to build that dashboard quickly to be able to onboard students. That's not the time to do a database migration.
Right.
So yeah, there's cases where data flow and what you're trying to solve will also dictate a little bit of when you're going to choose which paradigm. What are some gotchas around the DB to remote schema stuff? Because I can imagine there's some cases where there would be concern about, well, what if my remote schema goes down, or my upstream, if you will, if that goes down? Like, what are some fallback options I have, or how would you go about reasoning about when would you leave something in a foreign service versus potentially trying to migrate that all into a Hasura world, versus just saying, hey, this microservice or this service producing this API is optimized for the problem it's solving?
Yeah, so I think one of the biggest gotchas is, depending on what that remote schema is doing in the resolver, you can potentially wind up with queries that time out or are very slow, right? So if you imagine a query that pulls back 1,000 rows and you've got that join between the database and the remote schema. And so you're tossing 1,000 GraphQL input arguments over to this remote schema resolver. If that remote schema resolver is doing something that's slow, and it's got to batch process 1,000 inputs, that query might take 45 seconds. 2 minutes might time out. So a lot of kind of what I've seen and talking about this with other people, or when people have been surprised, is that just be wary of whatever is on the other side, and that it can potentially slow down processing, especially when you're doing nested GraphQL queries where you're a couple of relations deep, and then you start tossing like remote schema fields in there, and that can get hairy real quick. But yeah, that's probably the main one, I would say.
Okay. Yeah. So kind of how many nested operations are occurring.
And how
what the workload is. Yeah. Okay. Let's have a quick look at some of the quick practice of it. So I've got 2 schemas that are identified in my compose file here. I've got a CMS, and shout out to former employers, Graph CMS, because I gotta throw love. But yeah, so we got Graph CMS as a remote schema, which they actually have a very clean GraphQL schema, which is partially why I like to use them. And then I have a GraphQL wrapper on Mongo using Realm. So I think that's the name of the product. You've got Atlas is sort of the whole hosted Mongo, and then Realm gives you the API wrappers on top of it. So I've got 2 GraphQL schemas, remote sources, and I'm going to try to connect them in here real fast just to have a look at how it is. We'll go into depth on each of these topics later on, and we've got some great hosts, great guests coming up. We've got Yugabyte talking about DB to DB joins. We've got GitHub coming up to talk about actions and remote schemas with the GitHub ecosystem. So we got some really interesting shows coming up, but just kind of looking at the high level of this one. So what I've got on my student here, there's a couple of ways to connect this. One is I have the student quiz, which is just a very, very thin, I've got a quiz ID, and then I've got a class ID. So what I'm going to do is I'm going to try to connect the quiz ID to a specific quiz that is inside of my Mongo, and see if we can actually kind of pull some data off of that. It might need to be from student here. Probably from student here, actually. Got to remember what my model looks like here. So we'll say something like quiz result. We'll say from Mongo here, and probably just get all the quizzes where the student ID is the same as the ID of my student here. All right, we just had a cut because one of the reasons why we actually recorded this content is so that you don't have to see all of my goofs online. And so what you're going to see here is that with, for example, in the case of Mongo, we have to define permissions on the Mongo side as well.
Surprise.
Permissions, man, permissions. But that being said, what we do from here is we're doing the database. So we're doing from DB to remote source. We are doing the student ID, and then we're going to go ahead and grab the ID on that and say that's from my student's ID is going to be mapped to the student ID on this quiz result here. And we can go ahead and hit save. And so if we go back to the API now, and we just kind of explore that, we can see, so we have student quiz results for question 1. And we can now see what it is that they were submitting as an array of their question 1s for this quiz. Okay, so the data model here is a little fragile. It's not necessarily the point. But what is kind of interesting is if you look at that data model, if we were to actually explore, because we have it exposed at the moment, if we have a look at the quizzes in general, so now I'm actually browsing the Mongo API for here inside of Hasura. And if we look at the actual content here, we have this quiz ID field, which is kind of interesting because I actually also have one of those from Graph CMS, because I wanted to have my CMS user. So if we were to actually do now a remote schema to remote schema, we could go to the remote schemas part here. We can go to Mongo, and we'll do a relationship from here. And so now we're doing the remote schema to remote schema. So I'm going to say that my quiz, I think it's quiz ID. So from quiz here, I'm going to go over to the graph CMS field. We're going to say the mapping is going to exist on this query here, where I have to kind of look a little bit careful here. So it's going to be, this is the graph CMS fields. And so I call them tests over there. And so it's going to be that the test ID, I have to go ahead and say, so I have test plural, but I think that should be a one-to-one relationship. It's a drop down on where. There we go. ID.
Oh, okay.
And it's coming from the source field of Mongo called quiz ID. And so when I do that relationship now, I have to give it a name because, naming things is hard. I was trying to avoid it. We're going to go ahead and call this the original test, or we'll call this original quiz in this case. Again, naming conventions here, like, don't do as I do, just enjoy that it works. We're going to go ahead and now head back over to the API here. And if we go to this quiz field and we do a drop down, we should be able to get the original quiz fields, where we're going to be able to see things like the quiz name. We could see like publication stages, all the stuff my CMS provides for me. And we'll say something like description in this case. I think I had a description field, yeah. And that's a rich text field, so we'll just grab the text version of it. All right, and now we're back. So another little quick side trip into debugging land. Testing and debugging these individual services, like there are reasons why schemas are good. There are reasons why testing these individual services is fine. Small bit of debugging, but we got going here now. And this little whole empty where statement, you may have seen some of my content in the past connecting Graph CMS into Hasura. Where is a required field for input parameters, but in the relationship, we actually have it defined as the field is coming in automatically. So we don't actually have to define the value. We just have to say, you still need to see the where input. The where input is automatically filled in. One of the issues I had is that it's not actually on my ID relationship. I'd had a special field inside of Graph CMS called foreign ID. I created for this purpose of creating that sort of a foreign key relationship across boundaries, because otherwise you start to get yourself into some trouble trying to rely on different systems implementation of UUID or whatever else. That's neither here nor there. But what we have here is a functioning service. And so the last test here is actually to take essentially all of this. This is now 2 remote schemas. But if we were to kind of just follow along with our student here, and the student, we're able to see then something like their quiz result. And on that quiz result, we're going to go ahead and actually have a look at the original quiz. And we're just going to grab the foreign ID here of the original quiz. And again, we have to put in that invisible boundary here from the where input. But so we've got at the moment is we have original result. We're going to just grab, I think, something like question 1 here. And we have then the third part. So what we've got going on is our database federated to Mongo GraphQL schema, which is created a relationship from the Mongo to Graph CMS. And we've actually got essentially this really interesting relationship where we've actually been able to say CMS data gets to live in CMS, document store data gets to live in document store, and our local database data lives in a local database. And running all those together, we actually are able to get a total cross-boundary API where I'm able to see all of this really interesting information. So in this case, looks like my my information for the foreign for the original quiz is null, but yeah, no connection there for this specific quiz. Yeah, that's like a really powerful way to build and being able to connect these pieces of content together. You want to say?
Yeah, could you like maybe comment on the query and just show like which part is Postgres, which part is like Mongo, which part is Graph CMS?
Yeah, so that's a great great question. So if we were to say, for example, I think I have to do it after the end of the line here. So this is going to be Postgres, and then this is going to be the Mongo, and then this is going to be GraphCMS
From Mongo, right?
from
Like
Mongo.
Mongo.
Yeah, related to Mongo. So this is getting the input from the Mongo field. So this is getting the ID, the quiz ID from here.
Mhm.
Let me just run that again here real quick. So that's what I was wondering. I actually have to return the subset of the field. So the quiz ID has to be, or what you're passing in as an input to the nested remote schema or the related remote schema. You have to include inside of the query results and be able to do that. I just wanted to kind of touch on one last point. So one of the reasons why this is all powerful, right, and useful is if we come up underneath something like the data here, and we say something like underneath the remote schemas, underneath GraphCMS, and we put a permissions block on there, we could actually block, and I'd have to turn that on as a flag at the moment, which I don't have set up at the moment. If we actually, let me just go ahead and do that with the power of video editing. And so with that, now we have permissions enabled. Video editing is actually a nice feature, right? So we could actually have a functionality here where we say something to the effect of, like we're gonna, the student, for example, they would have like a student role, right? And we would be able to come in here and actually say exactly which bits of data they would have access to. So we could say something to the effect of, they wouldn't have access to like the answers, right? We'd be able to say that they didn't have any permission here. So if we just save this as is without defining any permissions, we can say they have access to like the ID, or we'll just turn this one on real quick just so we have something to show. And so now, just with IDs turned on, if I come over here to the to my API again, we're going to get some squiggly lines probably where we are no longer able to, I don't have the role enabled, but I don't have access to then as a student seeing the original answers. I'd ask her to create a JWT token and pass the role. Can I just turn on role like that here, or that will show me the same results?
Add x-asura-role and then put the role value in there.
Well, now we're locked down by a lot more on the permissions here, because I didn't give the student role permissions in general. But if we were to kind of look at the tests now, for example, we would see that we don't have anything except for ID available to us as that role, right? So this would be a way where I could say, well, students have access to being able to see some bits of the graph, but then people like the admins or the teachers could see all of it, or parents could see their students' results, or the guardians could see their students' results, and teachers could only see the students in their class. So you can start to get very granular with the permissions and controls on this inside of this federated graph. And that becomes the power of why you would actually do all of this inside of Hasura in the first place. Well, that's actually architecting the applications. I have taken up way more time from Gavin than I initially had requested, so I appreciate you sticking out here towards the end. Gavin, any last comments or thoughts to say to the users?
No, thanks for having me on, and Hasura is awesome. I hope everyone else thinks so. So please keep using it if you like it.
Use it if you like it, and if you don't, use it anyways.
Maybe not that.
That's a wrap for today. Really appreciate y'all coming out or watching this show. And if you like this new format, let us know. Give us some kind of a thumbs up or whatever. We'd really appreciate just kind of getting your feedback to see if you like this new format, where it's hopefully all faster, condensed. And yeah, have a great day. Happy building, and we will see you all on the next show. Bye.